The oil drop experiment. This is an experiment that can be used to estimate or approximate the thickness or diameter or size of an oil molecule. So the aim is to estimate the thickness of an oil molecule. This is based on the fact that oil forms a circular patch when dropped on water surface. In this particular experiment, we fill a pipette with oil and then drop a given number of drops on the water surface. The observation in this case is that oil forms a circular patch which is believed to be 1 molecule thick. We then find the volume of the patch, which is basically the volume of the oil drop. This volume is V and is given as 4/3 pi times the diameter of the drop over 2 cubed. We apply this formula because the drop is spherical. We then calculate the area of the patch formed. The area of the patch A, because the patch is believed to be circular, so the area is pi r squared. Since the patch forms the patch formed is circular, we believe that it is 1 molecule thick, and therefore it has a thickness T, which is given by the volume of the patch, which is basically equal to the volume of the drop, divided by the volume, divided by the area of the patch. In calculations, volume of the patch is normally given as 4/3 pi times the radius of the drop cubed, while the area of the patch is given by the formula we have here, pi times the radius of the patch squared. In order to make such calculations, we make the following assumptions. One, we assume that the drop is a perfect sphere. We also assume that the patch formed is a perfect circle. And besides this, we also make an assumption that the height or the thickness of the patch formed is a monolayer. By monolayer, we mean that the patch is one molecule thick. Example, if in an oil drop experiment, an oil drop of diameter 0.5 millimeters spreads on the surface of water to form an oil patch of diameter 0.2 meters. Estimate the length of the oil molecule and express your answer to 3 decimal places. One important thing that we have to note is the unit in which the lengths we have here are given. We have diameter of the drop, which is 0.5 millimeters, and we also have the diameter of the patch, which is 0.2 meters. In making calculations, we must ensure that the two lengths are in the same units. So we can decide to convert the diameter of the patch into millimeters, whereby we are going to multiply 0.2 by 1000 to convert it in millimeters. So when we multiply by 1000, we get 200 millimeters as the diameter of the patch. We then find the volume, which we get from the volume of the drop. The drop is assumed to be spherical, and therefore it has a diameter 0.5 millimeters, and we use that diameter to find the volume. So that volume is 4/3 times pi times 0.5 divided by 2 cubed. So when we do such a calculation, we have 4/3 multiplied by 3.142 multiplied by 0.25 cubed. And that gives a value of 0.06546 in 4 significant figures. We also find the area of the patch, which is pi r squared, which in this case is given as 22/7, times the radius, which is 100 squared. And that gives 3,414,28.6 millimeters squared. This one is in millimeter cubed. The length of the oil molecule, which is the same as the thickness and the diameter, L, is equals to volume over area, which is 0.06546 divided by 3,1,428.6. When we divide the two, we get 0.06546 divided by 3,1,428.6. This gives 2.083 times 10 raised to power negative 6 millimeters. As the length of the oil molecule.